All right, for today's lesson, we are continuing on with geometric sequences and series. And today we're going to start talking about the series aspect of these geometric formulas. So if you see here, we are going to eventually be able to calculate partial sums for our geometric series. Now on page 23, you will see here this vocab word, which probably is pretty familiar to you from your time in mathematics classes, and that's exponential functions. And what exponential functions are functions that are in the format a times b to the x powered. Now, the reason that's important to us is because in the last lesson we talked all about this lovely formula here: a sub n equals 8 times the square root of 3 over 2 to the n minus 1 power, right? And we were able to calculate our our geometric sequences, the specific terms, quite quickly if we had this formula. So we have our a term, we have our b term. So basically what we're seeing here is that geometric functions are going to be exponential, unlike their arithmetic counterparts that are linear. Now, take a moment on your own then to just test out number 2, calculate the 9th term in our lovely a sub n sequence. And then we also are going to talk a little bit, if you flip the page, then we'll skip number 3 because that's enough practice with that. If you look at number 4, we have a completely different geometric sequence, finally, and they want us to calculate two things, r and the 10th term. Now, a reminder from the last lesson that our r values are found by taking a specific term divided by its preceding term to get our common ratio. So if we have a second term of negative 3/2, we're going to divide that by its preceding term, 1/2. Now, notice when your two terms here, they are alternating between positive and negative. We know when that happens that our common ratio is going to need to be negative in order to have that sign flippage occur. Now from here, we have these denominators that cancel out, and negative 3 is what we are left with as that common ratio. Now from here, now that we have the common ratio and the first term, we can develop our formula here where we take that first term, our common ratio, and raise it to the n minus 1 power. And in this case, if we are looking for the 10th term, we're going to plug 10 in for n. And take a moment to practice a little bit of a calculator practice here, just because sometimes that's actually harder coming up with the formula itself. We have 1/2, negative 3, and then to the 10 minus 1, aka 9th power. And you see our final answer. If we have decimal, we have, you could leave it as that. Oops, and it's not turning into a fraction on this one, although you could write it as a fraction too, if your calculator will turn it. Okay, so from here, negative 9,841.5. Okay, again, we see how nice the explicit formula is to calculate those sums really quickly. And again, something I would definitely put in your notes is that explicit formula for a geometric, which is the first term times that common ratio to the n minus 1 power. Now, for arithmetic sequences, we talked about obviously a explicit formula as well, but we also talked about that lovely partial summation formula, right? The big S sub n. And we're going to do the same thing here is for our geometric, right? Our partial sums is when we are only adding up a specific number of terms. So 1 term, 2 terms, 3 terms, 4 terms, the first 5 terms, right? Those are our partial sums. Now, in order to derive this particular formula, we're going to start with taking our sequence that we've been talking about for the past 2 lessons, S sub n, and we're going to multiply those partial sums by the square root of 3. So if you take 8 and you multiply it by the square root of 3, you get 4 square root 3. And if we take 8 plus 4 square root 3 and we multiply it by, again, that square root of 3 over 2 out front, aka distribute it through, they want us to leave this expanded, notice, but what we end up getting is 4 square root 3 plus 6. Okay? And if we continue distributing the square root of 3 over 2 through each of these sums, we'll see these expanded forms here of each of these. Okay. Now you're probably asking, why do we need these? All right. What ends up happening on the next page is what you're going to see is they want us to take. They gave us the first one, the difference between S sub n and that square root of 3 over 2, the common ratio, times S sub n. So notice here we are basically taking this minus this each time, or this minus this each time. So you're going to essentially distribute a negative through all of those second pieces, right? So what happens here, we'll do the first one together and then we'll kind of cheat and calculate the rest. But so we have the S sub n was 8 plus 4 square root 3 for S sub 2. And again, we're subtracting away the square root of 3 distributed through. So 4 square root 3 plus 6, aka we are left with 8 minus 6. Now, what the second piece here then is we are basically saying this is equal to this because all we are doing here in this second column is factoring out our first term, aka for this, 8, right? A sub 1 equals 8. So we're basically taking out a GCF of 8 each time. So if we have 8 minus 6 and we take out a GCF of 8, we're left with 1 minus 3/4 here. Okay. And then this last column is basically telling us, okay, we're going to change this. We're leaving the A sub 1 and the 1 in place, but let's change these pieces right here to be R, aka the square root of 3 over 2, to the n power. AKA here, we're just raising it to the first power so that it's itself, but the, 3/4 is actually the square root of 3 over 2 to the second power. Okay, they're equivalent to one another. Now to save us some time, I have the rest of the chart filled in. But we basically went through this process each time. Now note that all of these are equivalent to one another. So what we have here is these are each equivalent to each other, right? We just rewrote it a bunch of different ways. But the important thing to note here is that this column right here is equal to this by the transitive property. And it's been a long time, all my geometry haters, since you've heard that term, right? So basically what we have is that this equals this. And the special little pattern here, you're probably noticing that our value is matching here to what term number we are looking for. Now, the next slide is again going to just take what we said was equal by the transitive property. And what we're going to notice here is that on this left-hand side, this is number 7, and then we're going to flip to number 8 on the next page. We have a GCF of S sub n with both of these. Okay, so 1 minus R, and that equals that A sub 1, 1 minus R to the n power. Now, oops, it's a terrible pen right here. N power. Now, what we're going to do is divide from the left-hand side to the right-hand side this 1 minus R, because now we have that S sub n by itself, which, if you finish here, ends up being our lovely formula for that partial summation. So all of that work was just to derive for us the summation formula for geometric, right? So if we wanted to add up the first 9 terms of Shelley's seashell sequence, so we expanded this out all the way, we want to summate 9 of these. Okay, we now have a shortcut to be able to do that using this formula. So sum of the first 9 terms is our first term, a sub 1, and then 1 minus our r value to the n power, so in this case 9, and then divided by 1 minus r. Now, rate your own calculator skills here, but I recommend, especially this one with all these crazy radicals and stuff running around, doing this as 2 steps. So I'm going to take the numerator first, and I'm going to type this in so that I get each piece here appropriately, all of the lovely parentheses. So there's my numerator, and then I'm going to divide that. Make sure you use parentheses here as you divide the 1 minus square root of 3 divided by 2. Okay, so we get our final answer of about 43.351. Okay, I cannot stress to you enough, 43.351. I cannot stress you enough the importance here of making sure you use parentheses, because, let me show you, if you just do divided by 1 minus square root of 3 divided by 2, your order of operations is going to mess this whole thing up, right? It's going to do divided by 1 minus this. So don't do that, okay? Make sure you are careful in your parentheses use. All right, now on that grim note, that is the end of this lesson. I highly recommend making sure, if you haven't already, jotting down our explicit formula, and then of course this summation formula for our geometric finite series. Thanks, everyone.